Okay, I'd like to invite Mr. Pandya, who is with the international organization that looks at irrigation. Maybe he can give us a big global picture about what are the systems that are being used, what works, what doesn't work, and what are you recommending to help with the water management at this time in the face of global climate change. Then we'll turn our attention to the more specific technologies that some have been shared, because there's some questions in the Q&A still waiting for Dr. Shani to address on drip irrigation, because that's one way to irrigate, especially for those who can afford it. Then those who can't afford it will probably have to rely on the traditional methods, which you, Mr. Pandya, will talk about. Yes, please, Ms. Pandya.
Thank you, Dr. Tan. And it's a great pleasure to be with all of you who are working towards agricultural sustainability. I'll share the screen now. So we'll be talking about the sustainable water management in agriculture in a global sense. The important thing is we need to appreciate the water resources scenario that is obtaining across the world, and what are the challenges that we have to face in a macro sense. So the issue is that agriculture consumes a very large component of water, but then the demands from the other sectors are also growing, and having reserved a lot of water for agriculture, naturally the agriculture will have to give up some water, and for that the maintaining and managing the efficiencies become the prime area. Also, our food demands are also growing, and with the growth in food demands, we will require more water in order to produce more food. And there we have to work towards the situation where we have to find the more productivity per drop of water. And for that, the new methods and management of water and the paradigms have to come in picture. And we also have adverse impacts from the climate change. And because of that, we'll be having a freshwater scarcity, increasing population, changing in lifestyle, and then rapidly growing water demand that is a result of all this. So our renewable capacities of the water is continuously reducing. And as we can see, we have gone down from 14,000 to somewhere around like 6,000 or 8,000. Because of the climate change, we are likely to see, I'm sorry, the slide is moving too fast. Because of the climate change, the global water consumption is also going to increase. The climate change will impact various countries in different manners. And then as we can see, the percentage change in runoff in some of the highly populated areas, and especially economically challenged areas in areas like, say, Africa, etc., are going to have a significant change in the runoff. And because of that, we are likely to find a very severe scenario. Simultaneously, as we discussed, even though the agriculture demand is to be maintained at a constant level, then also the manufacturing, electricity, and domestic demands are likely to increase. And with this increase that is coming in picture, the total global demands will go up, and which will have to be managed. This is a scenario of global water scarcity, where we find that a large amount of area has got a physical water scarcity, and physical water scarcity can be managed out of the more efficient methods and of the water management. So the issue of the climate change is very much upon us. We know what is the situation in the climate change, and those impacts are going to be most severe on water resources. The water resources are the ones where we will be having higher frequency of floods and droughts. Now, floods and droughts, both of them are affecting the water productivity. And because of the water productivity and because of the water demands, the increasing water scarcity is going to affect a very large part of the world. As we can see, this most of the parts which are colored red and deeper are the ones which are going to be very severely affected. And some of these parts, if we look at it, they are very important parts from the food and agricultural production point of view. So it becomes very much necessary that in order to become sustainable in food and fiber and nutrition demands, we will have to be very efficient, and we will have to manage our water resources more and more systematically. So as we said, we have to maintain this water and food security, and for that, the water for food is going to be something which we cannot avoid. The water is required for the food, and there the agricultural sustainability will have to come in the picture, which will have to become concomitant with water security. If you have water security, then only we'll be able to achieve agricultural sustainability. And when we have to achieve water security, we will have to look very seriously at what kind of efficiencies and what sort of dynamic planning that we are likely to have. So, as far as the sustainability needs are concerned, the sustainability of water is the one which we consider to be the most important, and that happens because of the need for the rural poverty alleviation and the irrigated agriculture. Because the irrigated agriculture is the one which represents 20% of the total cultivated land, but it contributes to 40% of the total food that is produced worldwide. So the irrigated agriculture has to be productive, and it has to be more productive than what it is already there. So this is the global scenario where we see how much water we are using, and there we find that it is basically the irrigated agriculture which becomes the backbone of the food security. Now in the irrigation scenario, now irrigation is having two major components. Number one component is of course the water, but the number two component is the irrigated area. The land areas over the world for agriculture are also getting restricted. And because of that, the irrigated area increase is also in a way tapering off. So we need to have more production out of the same irrigated area in order to meet the water demands. And now, as we have seen, agricultural sustainability is also deriving from a very major factor of the sustainability of irrigation. And there we have to have a multi-pronged approach in order to come up with these issues. Number one and most important thing is what kind of projects that you design. Irrigation is practiced at various levels. Irrigation is practiced at the farm level by the individual farmer. But then irrigation has to be practiced at a regional level and at a sub-regional level based on various irrigation schemes that we have to put in. And for that, the projects have to be built in. Now, projects require high investments, a lot of management of the natural forces, also of the land, and also of the societies. They also have unlimited lifespans. The irrigation projects that we come up with cannot be decommissioned forever because the food demands are growing and we don't have the affordability of throwing away something. So they have unlimited lifespans, and during their lifespans, we are likely to encounter the effects of climate change and various other issues. And for that, we need to come up with a dynamic management regime. Our global, our macro water resources in the form of irrigation schemes with the headworks and with the various distribution networks, they have to have a dynamic management regime. And that dynamic management regime will go towards climate change adaptation and disaster risk reduction. So the poverty alleviation or the food security will come only through these irrigation projects, socioeconomic development coupled with these projects, which will ultimately lead to poverty alleviation. So there are multiple management aspects that at a macro level that irrigation is required to undergo, where we need to check about the resource management, how much resources available. You see, our resources are basically random. We get the rainfall mostly, most of the world, we get the rainfall, and it is the rainfall which ultimately results into the runoff and water. And there, the randomness create a scenario where we will have to manage that randomness and simultaneously match the demand patterns along with the randomness. We have to maintain and manage our irrigation assets that we create at a great cost, like distribution network management, the safety and assurance of major structures, because they have to continue to perform at their design level throughout the life, and life is practically infinite. The handling of natural and man-made disasters on such a widespread kind of a network, as well as such large structures, is also very huge, and that also has to be managed. And then, of course, we have to also look at, and we have to specially look at the on-farm management, because that is where we can make an impact on the water consumption that we have. So these are there are various kind of models that we have. We basically look at the sustainable irrigation management through those models, where our guiding principles become the managing or balancing the availability and demands, that how much demand is there and what kind of availability is there and how do we match them. What are the interventions that are required from in the view of the structures, in the view of the networks, in the view of the technologies, and then the governments at the global level have to promote those technologies and those approaches. So the availability scenario has to be, as we said, has to be really looked at very, very carefully. The demand growth also has to be really looked at very carefully. What we see here in India is that once we made the water available, the demands for on those waters also underwent some kind of a great change, and more high value crops came in, which were essentially more water guzzling, and it actually creates a kind of an artificial water scarcity. And this managing the demand growth along with the economic growth, and there the sustainability of the agricultural model that is adopted by the community really comes in. So the demand growth becomes a part of the overall management growth. There are so many technological interventions about which my previous speakers have already spoken a great lot. And after that, after these technological interventions, how do we really manage those technological interventions? Because the technological interventions become sustainable only if the society and the community adopts them well. And for that, a consultative system between the system managers and the beneficiaries that need to be formalized to define the problems being encountered and their solutions. The economic sustainability is the one which will ultimately allow or make a particular farmer or a particular system adopt a particular type of solution. So the economic sustainability of the overall models is something that the agricultural sustainability has to look at. The community has to adopt it, and community will adopt it provided you have the economic sustainability, you have the capability to manage them at their local levels, and have a comfort level with the measures that are being provided in their socio-economic setups, and also the reliability of those measures that are being provided for. So there are so many prospective areas for the future management which will go towards the improving our agricultural sustainability. And with the agricultural sustainability, we will have to work for the food and fiber security. And there, at the ICID level, we especially look at the technological interventions and the capacity building, so that if the capacities are built, then the entire area of agricultural sustainability becomes possible. I'll give you a very brief about the ICID. We are a large global organization, international organization, which was established in 1950, and we have an area of about 90% of the irrigated area across the world is comprised by the countries who are all our members, and we dedicate ourselves towards the alleviation of the poverty and sustainability models. And we have our vision is the water secure world free of poverty and hunger. We have very flagship events across the world. We also provide with a various thematic and other support to the global community, and we provide you with a vision 2030 in which against which we are working continuously in order to make the world sustainable. So thank you very much. I think I have tried to manage as much as possible within the time, and I'm really happy to be here with you and share these thoughts, which will be beneficial to all of us. Thank you very much.
Thank you, Mr. Pandya. Now I'm going to ask the questions to Dr. Shani on his drip technology, which is one of the things that they can use to address irrigation. There are some questions posed earlier, so let me see. There is from Eco Sulius Tono, who says, I would like to ask Dr. Shani how much the discharge of emitter in NDRIP.
In order to, yeah.
What's the cost of it, I think?
Yeah. In order to make the system simple, I decided on one discharge, and because according to my experience, and I have a lot of experience, one is good. So it's about 1.2, between 1.2 to 1.5, depend a little bit on the conditions. And if we want to change the amount per area, I mean, if we need more, we can make the drippers, we change the dripper density. So normally we use a dripper for field crops. We use a dripper like every 55 centimeters. So it's relatively quite a lot of drippers, but for example, for potatoes or for rice, I forget to say, but we now build a solution for the rice because we are very good for smallholders, and we can work together with a flood to start and then our system to continue. So it gives a very efficient method to grow rice. But so in there, it will be 33 centimeters or 40, depends on the conditions. So we change the discharge. So the dripper is single, but we change the density of the drippers.
Okay, then Francis James Naong asks, is there a limitation that affects the system? What if the source of the water is too far? How far can your drip irrigation lines go? The distance, I think.
Oh, it's a good question. We use today the NDRIP fields to 600 meters. Normal drip irrigation, pressurized, irrigate to about 200, and we irrigate 3 times more. It's very strange because we use very little energy head, and we can run it for very long distances. The reason is that if the field has just a little bit slope, like any field of flood, so we have a running head with us, so we can use. So anyway, the answer is 600 meters, which is about 3 times. It's
3 times, yeah.
Yeah, it's very good for most flood irrigated fields.
Okay, the next question. From what you're saying, this installation of your system is highly customized. So anyway, Nabin Dungana asked, how about the total costing for establishment of this technology? I suppose it means implementing your technology. I don't think it's asking how much it costs you to invent it.
So I showed the cost. Of course, the cost depends a little bit on the size, on the slope, on the crop, you know, on the availability of tubes or panels. But basically, we take it to be, let's divide it to 2. In the first year, we need to install also the drum and the distribution pipe. And so a system at this stage is about, we speak acres or hectares. Okay, I'll speak acres. It's okay if not, but
Yes, it's okay.
you want,
They
okay,
can
so
calculate, yeah, they can
per
calculate.
acre, it should cost something like between $600 to $1,000 per acre for the first year.
Mm.
The difference is because if you want for rice, you need more drippers and more laterals. If you want it for cotton, we use much less drippers. So this is a difference. And then this includes the capex of this includes the more permanent part, like the drum and the distributing pipe and the laterals. The laterals from that is about half. So for now a system like that, normally we design it for to keep for 3, 4, 5 years with good maintenance, depends on the crop and so on. So it's absolutely affordable. Think that it costs like per year, it costs a little bit more, $150 per acre. This is very little. And
So
then you have no OpEx because you don't need any energy.
Yeah. You don't have to go there and water and make sure that.
As a matter of fact, even if we compare it with flood irrigation, it's cheaper than flood irrigation because we use half of the energy. They need energy. We don't use energy in the field, but the system normally need energy to bring water to the field. Even if you use it from a river or use it from for sure if you use it from wells. So because we cut half of the water, we also cut half of the energy. And we cut half of the fertilizers.
Yeah.
And fertilizers, as you know, today, it's expensive. So our system costs less than flood.
Okay, one more question from Vijay Bhaskar Dinepu, who asks, is N-Drip available in India to buy and install for my farm?
It is starting to be available. It will be available. I can tell you that I got today a request from the water minister in India, the federal, to start a plan for India for rice and other crops. So we sell today mostly to PepsiCo farmers in Punjab and UP. But India is an absolute focus for us.
Okay, so that is the questions that you have. For Jason, you have one question. Have you done any research on electrolysis for water treatment? And before you answer that, I'm going to ask the panelists to think of a question in general that we can discuss after I bring in Dr. Yu to talk about Taipei and what he does on irrigation in Taipei as part of ICID. The question I have in mind is, what have you found that governments do to help get this water management going? Because I think if they give incentives for technology introduction, that makes life easier. But I don't know. That's a question for the panel to share afterwards. But Jason, over to you. Any research on electrolysis for water treatment?
Sure. Yeah, so let me just talk a little bit about electrolysis first, right? Now, electrolysis depends on what specific area you are intending to deploy it in. Now, most of the electrolysis technologies are using it for disinfection, right? Because they just dose in a little bit of sodium chloride. You use electrolysis to basically split the chlorine off from the sodium, and you use your chlorine for cleaning. And many of the large companies are doing it. I believe companies like Toray in Japan is doing it. We've even received requests from companies to use electrolysis, not just for agriculture, but for something as simple as replacing your swimming pool water with electrolysis water, right? And their claims are that the chlorine in the electrolysis water is actually safer than the chlorine that is being dosed into your swimming pools, right? So we have a lot of requests on that. Now, the question with the use of electrolysis has also got to do with regulations, right? Now, one of the regulations in Singapore, at least for swimming pools, is that there is a mandatory requirement to dose in chlorine, right? So if you have to dose in chlorine, then it sort of defeats the purpose of the electrolysis process altogether, right? And I'm not so sure whether agriculture has any regulations on the use, because what happens is after you've done your electrolysis of water, you are going to have this residual antibacterial effect. And if you water your plants with that, you may actually kill off the good bacteria that is on your plants and especially your plant roots that is helping to allow the water transport and the nutrient transport into the plants. So that's something that could be of a concern. So that's why I had a reply to ask specifically, what application are you interested to do for electrolysis? Because if you intend to use the water after electrolysis for irrigation, you may need to do further treatment to remove the chlorine from the water, right? So you may be treating it, but you're actually adding another problem because you need to replace or remove this chlorine from the water after you've treated it. So that's one thing. And of course, the other angle of electrolysis is that we have done some electrolysis with ion exchange membranes to look at whether we can split the water into acid and alkaline components, right? And acid and alkaline components both also exhibit cleaning capabilities as well as antibacterial effect, right? And I can mention this because we've done a few studies, not for agriculture, but for cleaning tower discharge treatment, right? Many of you, if you are experiencing an air conditioning now in your offices, it's thanks to the chilled water cooling system provided by your buildings, right? And many of this water is actually being discharged into the sewers, right? So it's not agriculture, but we've done the electrolysis treatment there, and we split it into acid and alkaline because it actually helps to remove the hardness from the water, right? So perhaps if you're looking at electrolysis from the purpose of removing the hardness of the water for your irrigation, that could be potential, right? But again, the electrolysis is just one component of the treatment. You still need subsequent processes to remove the physical how should I say, the physical particulates that comes out from the water when you do this process, right? And you are going to end up with some physical precipitation of your mineral salts coming out, right? So you need to have a way to manage that. So this electrolysis by itself is just one element. It really needs to look at what are your intended application. And I would say that's the best answer I can give you. It's not a very good answer because it really depends on what's your water quality and your application.
Okay, the questioner asks, we're interested in electrolysis in irrigation and sanitization.
Okay, if it's for sanitization, then that is a potential.
For
right?
agricultural products like fruits and vegetables, would you have any? The person is Dennis Lim, he wants to know that. Yeah.
Sorry, what was the question again?
We're interested in electrolysis in irrigation and sanitization of agricultural products like fruits and vegetables.
I see. Yeah, well, that is possible because that will help you with antibacterial. It will remove any bacteria on the fruits and vegetables. Of course, in agriculture, well, we work with chicken farms. So on chicken farms, at least they are concerned with salmonella, right? And it's probably the same for other fruits and vegetables. Maybe salmonella could be an issue, right? We have not actually tested the efficacy of the electrolysis against salmonella per se, but that is a potential because it has shown antibacterial properties, right? And we do use it for cleaning. So if you want to use it for fruits and vegetables, you could say it is actually potentially much safer than using any other chemicals, right? So that is one of the advantages of the electrolysis, and it's fairly sustainable, right? You are just using electricity to do it. Yeah, so that's one option. And the residual effects it persists in the water, right? So that's actually quite important because if it only works when your system is operating, then you need to keep your system operating and you incur a high energy consumption. Right, but with electrolysis, we do see a residual effect, and maybe just an interesting point to note, even in the project when we split into the acid and the alkaline water, even after we recombine the acid and alkaline components back together to neutralize, the neutral water still exhibits antibacterial properties, right? Just in case you are wondering. So you do have ability to play around with the electrolysis water for sanitization and treatment of your fruits and vegetables.
Thanks. Okay, I missed one question. It looks like a question anyway. It says, Uri Shani asks Dr. Shani, It is idea of gravitational drip irrigation can to include creating artificial rains for gravitational irrigation. That's question one. I think he's asking whether you can combine it with artificial rain. Okay, then the other one is this the best and most trustworthy protection from water storage in result of climate change? Dr. Shani?
Okay, I hope I understood the first question, and I'll say that what we need, the answer is practically yes. We need a source of water that is about 50 centimeters above the field, and of course it needs to be large enough. I don't mind if it comes from a reservoir, local reservoir, or it comes from the canal, that comes from the river, or comes from this. I don't mind that. The one problem that you have from gravitational rain, or I mean, boreholes, or is that at times it can get really affected by algae and other plant, and so it could be turned to be kind of a soap. So, I mean, when I say that we don't use any filtration, it's okay to a certain level. Of course, we need what we call at the end water. If we don't irrigate with soap. So this is the only limitation. From the rest, the rain or gravitational rain or artificial rain, it's all of it, it's okay for us. Can I add one comment to the previous? We were thinking a lot of how to deal with the hydrogel or biofilms in our systems, because if we let the particles to go into the pipe, then we have, of course, bacteria and fungi and all those kind of things in, and we have a problem of biofilms or hydrogels. And since chlorine is kind of forbidden in many places, we found that for all those, for agriculture, for large quantities of water, and this is one of the problems of your method, hydrogen peroxide. Hydrogen peroxide for agriculture works perfectly.
Yeah.
Just, you know, complementary.
Yeah. Okay, Dr. Yu, irrigation in Taiwan. Are the technologies being used? What technologies are being used and what's being done in the general system? Do they have a problem or they have enough water? There's so much typhoon seasonal anyway.
Okay, I thank you. Yeah, thank you, Dr. Tan, and yeah, so many inspiring talks. Yeah, from the speakers. Yeah, for Taiwan, we also have agricultural water is also occupy about 70%. As yeah, similar to the other areas in the world. And yeah, as mentioned in the moderator, that yeah, we have a lot of water, but yeah, and because of typhoon, but we also suffering about the droughts because of the uneven distribution of our rainfall. Yeah, we have a typhoon during summer, but so they rain a lot. But in the south part of Taiwan, yeah, during the winter, the dry season, we don't have enough water to do all kind of irrigation, especially as you also know that in Taiwan we have a very urbanized area, so the agricultural water resources have serious competition from domestic and the industrial water uses purposes. So the water management is very important in Taiwan. So currently in Taiwan, yeah, the government try to develop propose several approach to try to, as mentioned in the talk of the Dr. Hu, they try to connect all the pipes from the North Taiwan to the South Taiwan to increase the flexibility of the water resources transfers because in northern Taiwan, we have the more abundant water resources over the year, but in southern part of Taiwan, they have this very serious the seasonality of the rainfall. So we're trying to increase this flexibility, but it's also very difficult. So other choices, the government also proposed and trying to invest a lot of money to do this. One part is we try to increase the management of the groundwater usage, because in Taiwan, we have a lot of rain over the year, even though the spatial temporal distribution is not even, but the groundwater resource is abundant, but because in the past the bad management approach, it caused some land subsidence in many areas and caused a lot of issues. But so now, but because we have still a lot of the groundwater recharge, so how to use properly the groundwater is important factors in Taiwan so far. And so also like in the talk of Dr. Tang, and he give us the water the treatment approach, and so in Taiwan because we have a lot of industrial area, and because the land use, we have some kind of mixed industrial and agricultural area, they mix together. So reclaimed water is also a solution we are now looking at. We're trying to develop some the advanced water treatment approach, trying to reuse the water after the second or third use of the water from industrial or domestic or the agriculture, the water, and the reuse to the irrigation. So this is also the government trying to look into this. And Dr. Shani proposed the drip irrigation technology. Actually, we have in Taiwan some researchers, and I believe the government also pay a lot of attention in this kind of new technology, the drip irrigation. Even though we, as mentioned in Shani's the talks, flood irrigation still dominate our irrigation in Taiwan. But the drip, because in Taiwan we have a very high mountain in many areas, and so the flood irrigation is somehow very difficult to transfer, to promote in some areas, especially like in the mountain part area, the mountain part area. So, and in the farmer at those area, they have to identify the water source by themselves. So they need the more saving water, the irrigation approaches. Like, so the drip irrigation techniques is now also, I think the government, we looking at this kind of the techniques significant. Also some new technology, like we're trying to using some special technology like remote sensing, and trying to improve our control system to do the water delivery. So this all kind of this combination, we try to improve the irrigation efficiency. So this is, as far as I know, all the government put the resources here and there to try to do the supply management and the demand management in for the agricultural water resources. This is what I want to share the status in Taiwan. Okay, thank you.
Chloe, our time is up, but I think we want to have one last question that I posed earlier. What about the role of governments? What do you want to say to tell us about what governments have been helping or not helping or should be helping to help a whole area of sustainable water management for agriculture? Any ideas? Any thoughts?
I think in Taiwan, so maybe I want to tell about the Taiwan so far the status in Taiwan. Our government actually trying to helping the farmers to have a better quality and stable irrigation waters and in entire part of the Taiwan of the farmers. So recently in our government, they actually reorganize the government, the functions. We create actually new ministry to look into the agricultural water resources, and one ministry, one bureau is focused totally in the agricultural water management, and I think this is so far very welcome by the farmers, because before the farmers in Taiwan, the farmer divide into two different categories. One category we have a very good, relatively good irrigation systems. Another part is not. They have to identify irrigation water resource by themselves. But now, the government trying to intervene in this part, and so the government is trying to provide the best supply management in agriculture systems, and also trying to educate the farmers to better control their water demand, irrigation water demand in our agricultural society. That's what I share in our government the strategy. Okay, thank you.
The other panelists, anyone want to share? Dr. Shani, is the Israel government helping farmers introduce your system? Or is this purely they have to find their own money?
No, in Israel, Israel is the only, I think, state in the world that they cannot use my system.
Cannot use your system?
No.
You're not Israeli.
No, it's they 100% not use my system. Israel is the only, I think, I've been the water commissioner of Israel. And according to my knowledge, Israel is the only state that farmers buy the water pressurized. It's so stupid. It costs a lot. It doesn't make it does, but to change it today, it's almost impossible. I just wanted to respond to the last. Do I have one sentence? Can I have?
Go ahead. Yes.
Okay. I think that one of the main problem, or maybe the main problem in water use efficiency in the world is that governments in general cannot raise the price of the water for agriculture. And it's simply impossible for them to do it. It will create demonstrations and so on. It will increase the price of food. So governments cannot use the main tool that will force water saving. They cannot use it.
Mm-hmm.
The only place that in Israel we did it, it was extremely difficult, and because of that in Israel, all the water is pressurized, as I said, and we use 75% is drip irrigation, and the rest is sprinklers. If you don't have the tool that make water valuable, you have no way not to force, to persuade people to save, because anything that is free is free. Yes. So the world, and then now if we come to governments, the government cannot use the main tool, and the government, so they need to subsidize. And we all know that subsidies are not the best way to help. It's the wrong way to help, because it brings with it, it costs money and it is inefficient. And this is the situation today. Anyway, that's including California, India, China, Africa, anywhere. And this worth a very serious discussion, but this is what that's a fact.
Jason, I don't have to ask you because yours is totally government funded to help, right?
Well, in a way, I do echo what Dr. Shani has mentioned. recently, in recent years, actually, Singapore also increased the water price, right? And they increased it across the board. So the farmers are also hit by the increasing water price.
So
And
there's not to save, I promise you.
yeah, so we do see a lot of requests, but then the problem with supporting farms is that they have very little money to pay for the high technology that is required in order to save that money on the water side. And CAPEX is just one of the problems, right? Then OPEX is your maintenance issue. You see, so you're going to get hit not just by the water price, but by the CAPEX, the initial investment. Yes, the Singapore government does come in to support subsidizing the CAPEX infrastructure, but then they don't support the OPEX, right? So you may get away with a cheap system, but you can't afford to maintain the system. And what we do see in the industry is that they buy the technologies, and after they use it for a year or two, they switch it off. And they just can't use it anymore, right? And this is a very, very common phenomenon. So this is an area where we don't explore how to keep these businesses running. We explore only how to push them to technology, but not how to sustain them holding on to that technology. So that's the one area that we really do need some help in.
Yeah, understand. Any closing thoughts, Mr. Pandya? You have many years of experience looking at all these things happen, and you talk about juggling to find funding for all these projects.
Yeah, thank you very much. Really, yes, as Dr. Uri pointed out, or Jason pointed out, it's a very complex kind of situation. I have a lot of experience in this developing parts of the world, and especially in India. And the fact remains is that the agricultural sustainability gets linked to the water sustainability, and coupled with the economic output that the farmers desire out of the agricultural operations. Because of the historical reasons, the water has been delivered in most of the parts of the world as some sort of a facility or some sort of a grace, and not exactly as some sort of a commercial good. So because of that, like when we very precisely measure the energy and we have it as an economic good, the water is basically becoming a welfare good. And that is more so as the developmental level of the society goes down. So the issue of maintaining the agricultural sustainability is coming out of the fact that the community has to be educated about the limitations of the resources that are going to be available to them, and then a kind of a promotional efforts with which the agricultural sustainability and with better water productivity can be achieved. So what we see here is that in the areas which are relatively short of water, where people have realized that the quantum is finite and they cannot really make do with the conventional methods, the more efficient methods of irrigation field application like sprinklers or drip are catching up. But then in those areas where people still have a kind of a luxury, or people still have a more stable and more higher source available, those areas are finding it very difficult to adapt to this additional productivity measures because of the reasons that the higher investment is required, the change in lifestyles are required. You have to change yourself in order to implement this new technology, and then the technology has to sustain. Most of the work that gets done at the field level, or even at the laboratory level, and then at the controlled field level, gives very promising results. But then when we go out into the field and then try to put it over something like, say, 1 million hectares, and then the new and unexpected problems come in, and unless there is a very continuous dialogue between the beneficiary and the supplier, and there is an intermediary who is able to respond to the demands of the ultimate consumers, this entire network, if it is not working simultaneously in one way, then the technology demonstrators work very well, and then when you scale it up to the field, the issues ultimately, many times they'll end up defeating the whole thing. So it's a complex issue, and it has to be addressed at a very, very macro level. You would have seen it in India that when you try to make an economic sense to the agriculture, there is a lot of societal resistance from the specified groups, and that way it creates a problem at the governmental level, because they have to remain popular as well to get re-elected. So in a way, I see it as a problem which is quite complex, starting from the farmer level and going all the way up to the highest levels of technology, as well as the political governance level. Yeah, thank you.
Okay. Thank you, panelists. Thank you for an interesting discussion. We know the big issues, and we also know the technical details that are needed. And we also confronted with the interesting situation where there's a solution available, but nobody wants to use it in Israel. Thank you all very much. I hand over to Chloe now to close us off for today.